Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 5.1, day 1, entitled The Unit Circle. And today we're just going to review what you know about the unit circle. We're going to talk about the equation of a circle as well. And then we're going to talk about some very basic terminal points on the unit circle. And as we talk about the unit circle in this section, you need to keep in mind that the unit circle is basically just a circle that's made up of all the points that are 1 unit away from the center. So here's our center of our circle, and we don't know what this unit is. It could be 1 inch, could be 1 foot, could be 1 mile. Doesn't matter what it is, but it's 1 unit. So all of these points going around the circle are 1 unit away from the center. And that's why we call it a unit circle. And we also have the equation for our unit circle down here. X squared plus y squared equals 1. That's the generic equation for a circle. And usually we see it as x minus h squared, and then y minus k squared equals the radius squared. But here, our center is 0, 0, so that h value and that k value are going to be zeros. So x minus 0 is just x, and y minus 0 is just y. And then our radius is 1, and 1 squared is 1. So they're substituting a radius of 1 and then the center of 0, 0 into that equation. And that's how you get this equation listed by the picture. Okay, now in class we're going to spend a lot of time talking about what you already know about the unit circle. You did work with the unit circle last year in Algebra 2, so this shouldn't be a completely brand new concept to you. And you should be able to tell me a lot about this circle, even if you don't really remember a whole lot. On the previous slide, we talked about how this point in the middle is going to be 0, 0. So that's your origin. And you should know that regardless of what class you're in. A freshman in algebra should be able to tell me that. And then if you know that the radius is 1 unit long, you should be able to tell me that this point over here is 1, 0. And then this point up here on the y-axis would be 0, 1. And this point back here would be negative 1, 0. And then down here should be 0, negative 1. Okay, so again, this is your x-axis, and you have your y-axis as well. You could also tell me degrees. There's 2 basic units that we're going to be working with throughout this whole chapter, with degrees and radians. So you're very, very comfortable with degrees. We talk about that mostly in geometry. And hopefully you remember that when you start at your unit circle, you're kind of starting at this ordered pair 1, 0, and then you go around it counterclockwise. So you should know that this is 0 degrees here. And then if you go up to the y-axis, that's going to be 90 degrees. And then if you come back to the x-axis, that'll be 180 degrees. You know that a straight line is 180 degrees. And then if you come back down to the y-axis, that will be 270 degrees. And then if you go back to the x-axis, that's 360 degrees. There's 360 degrees in a circle. Now this picture I really like because it breaks the unit circle up with these other little dashed lines. And those are going to be important measurements that we're going to use a lot. They're very common measurements that you see a lot in geometry. And if we just look at this middle line here, that divides that first quadrant in half. So that's going to be 45 degrees. You'd have 90 degrees. And then halfway between 90 and 180 would be 135. So that's the same as taking 90 plus 45. 135 plus 45 is 180. So then halfway between 180 and 270, you're going to take 180 plus 45, and then you'll get 225 degrees. Add another 45 to that, you get 270. And then again, halfway between 270 and 360, we have to add 45 to 270, and you would get 315. And add 45 to that, and you get 360. And then these other two lines here are going to be divided into 30 degrees and 60 degrees. Now, hopefully you remember dealing with 30, 60, 90 triangles and 45, 45, 90 triangles when you were in geometry. That's where these measurements are come from. It's related to that as well. Okay. So this first little dashed line here, this is every 30 degrees that we go around the unit circle. So if you go another 30, you'd get to 60. Another 30 is 90. Another 30 is going to be 120. Another 30 will be 150. Plus 30 is 180. Plus another 30, that's going to be 210. Plus another 30 is 240. Plus 30 is 270. Plus 30 is 300. Plus 30 is going to be 330. Plus 30 is 360. So using that 30 degree section helps us get measurements for all of the 30 degree sections and all of the 60 degree sections. So I've got my 60 degrees and then my 120, and then another 60 is 180, another 60 is 240, another 60 is going to be 300, and then another 60 beyond that is going to be 360. So those are all the degree increments that are going to be really key and really important. Hopefully, if we can find these measurements on the unit circle or in a problem that we're dealing with, the unit circle is going to help us do some shortcuts in our calculations. So if we know these measurements and all the facts related to them, it can help us do our calculations much quicker. Now, the unit circle also gets divided up into radians, and we talk about that in a couple of the slides coming up in the future. But hopefully you remember that if you go 180 degrees around the circle or 360 degrees around the circle, 180 degrees around is equal to pi, which is 1 radian. And then 360 degrees around, that's going to be equal to 2 pi, or 2 pi radians. So radians are always measured in degrees. So for our radian measurements, if we start at 0, we could go all the way over 180 degrees, that would be pi. And then if we go another 180 degrees around, that's going to be 2 pi. So you have 0 radians here too. And then if you cut that in half, if you go from 0 to pi and you're going halfway between them, that's going to be pi over 2. So there's going to be a lot of fractions here in our unit circle as well. Okay, and then if you're going from pi to 2 pi, but you only go halfway, that's going to be like 1.5 pi, or 3 pi over 2, 3 halves pi. So get used to improper fractions. Get used to counting with fractions and reducing them. Okay, and then the 45 degree angle mark, that was halfway between our 0 and 90 degrees. So we can have a radian between 0 and a half. Half of a half is going to be a fourth, so you'd have pi over 4. Then you'd have another fourth, which is pi over 2. And then if you have a half plus a fourth, that's going to be 3 pi over 4. And you add a fourth, and that's 4 pi over 4, or 1 radian, 1 pi. And then if you add a fourth, that's going to be 5 fourths, or 5 pi over 4. If you add another, that's going to be 6 pi over 4, which reduces to 3 over 2. If you add another fourth, that's going to be 7 pi over 4. If you add another fourth, that's going to be 8 pi over 4, which reduces to 2. 8 over 4 is 2. And then we could also go every 30 degrees or every 60 degrees, and we could count that in radians as well. The way we want to think of that, though, is again in fractions. And if you look at these 30-degree marks, how many of those 30-degree slices are there just in the 0 to pi? So we'd want to count 1, 2, 3, 4, 5, 6. So in that first half of my circle, in that semicircle on the top, there's 6 of those 30-degree sections. So if I want to get all the way around here to 1 pi, that would be 6 out of 6. So that means every 30 degrees is going to be a pi out of 6. Okay? So then I have 1 pi out of over 6, 2 pi over 6, which is going to be pi over 3. And then I would have 3 pi over 6, which would be pi over 2. Then I'm going to have 4 pi over 6, but I'm going to reduce that to 2 pi over 3. And then I would have 5 pi over 6, and then 6 pi over 6, which would be 1. Then if I keep going, I have 1 plus a sixth would be 7 pi over 6. So again, get used to those improper fractions. Then I'll have 8 pi over 6 here, but I'm going to reduce that to 4 pi over 3. So it's 8 over 6. Then I would have 9 over 6, and 9 over 6 would reduce to 3 halves. Then I would have 10 over 6, and that's going to reduce to 5 pi over 3. So that was 10 over 6. And then if I added another sixth, I'd have 11 pi over 6. And if I added one more sixth, I'd have 12 pi over 6, which would be 2. So this you should be able to create on your own. You should be able to know this and draw this and reconstruct this. If you need to draw this on a little sheet of paper and then have this out kind of as a reference, that's totally fine. You can draw it on the top of homework and quizzes, etc. Okay, so again, we have our equation for our unit circle here, the x squared plus y squared equals 1. So the first few examples here that we're going to do are going to be reviewing that concept. Okay, so example 1 and then example 2 are going to have us doing a couple problems with our unit circle equation here. It says to show that the point square root of 3 over 3, square root of 6 over 3 is on the unit circle. And remember, our equation for our circle is x squared plus y squared equals 1. And if I'm given this point, remember, this is an ordered pair, and the first value in that ordered pair stands for the x, and the second value stands for the y. So I'm just going to substitute those values in. So I'll have the square root of 3 over 3 that I'll substitute in for the x, and then the square root of 6 over 3 that I'll substitute in for the y, and then I'll simplify it. If it equals 1, it'll be on the circle. If it doesn't, then it's not. Okay. Now they want us to show that it is on the unit circle, so hopefully when I square everything on the left side of the equation, it's going to end up equaling 1 after I add it together. Okay, so remember, when you square a fraction, you square the top and you square the bottom. So the square root of a radical is just that radicand, and then 3 squared is 9. Square root of 6 squared is going to be 6. 3 squared is 9. So then I have 3 over 9 and 6 over 9, so that's 9 over 9, which is 1. So there we go. We just showed that that point is definitely on my unit circle. Example 2, we're still going to use that same equation, except now they want us to find the y value. They said that the point, the square root of square root of 35 over 6, y, is on the unit circle in quadrant 1. Now that information is going to come in handy once we actually find the value for y. So find the y coordinate. So they've told me that that point is on my unit circle. So then I'm going to substitute in my x value, square root of 35 over 6. I'm trying to find the y value. So let's see, if I square the square root of 35, I'll get 35 over 36 plus something squared equals 1. Now it looks like just an algebraic equation that I have to solve here. So I'm going to subtract the 35 over the 30 over 36. So that gets me 1 out of 36. Because remember, 1 is 36 over 36. If I subtract the 35 over, then I have 1 left. And then to solve this, I'd have to take the square root of both sides. So technically, when I take the square root, I get plus or minus 1/6. But that's not my answer, because I want the value for y that would be appropriate for the first quadrant. And remember, in your first quadrant, your x value and your y value are both going to be positives. Positive, positive. So my y value is going to be 1/6. Okay, so you're going to see some problems like this in your homework where they're having you work with the equation of a circle. You've worked with this before. You've seen it in geometry. You saw it in Algebra 2. We saw it earlier in the semester. So again, this is just another extension of how you can use that equation with the unit circle as well. Now our last concept for today is just to talk about some terminal points. And this kind of reviews some of the stuff that we wrote down earlier when we were filling in our unit circle. Remember that when you are looking at the unit circle, you want to start on the x-axis. Okay, so we're going to start at the point 1, 0, and then you move counterclockwise if your direction is positive. And if your direction is negative, then you're actually moving counterclockwise. So I kind of like to say that when you start at 1, 0, if it's positive, you move up and go around the circle that way. If it's negative, you go down and you move around the circle that way. Now, anytime you are given a distance and then you stop, whatever point you stop at is called your terminal point. Okay? And like we said before, the circumference for a circle, remember circumference, the equation is just 2 pi r. Okay? But on our unit circle, our radius is 1. So your circumference on a unit circle is just going to be 2 pi. That's why it takes us 2 pi rotations to go around the unit circle one time. Okay, so 2 pi is that distance that we can travel around the unit circle one time. Okay. So if we start at 1, 0, and then we go around the circle counterclockwise, 2 pi, we end back up at 1, 0. We end at that same point that we started at. So your starting point and your terminal point could be the same point. And then, like we said, if we move halfway around the circle, then we would be at pi. If we move a quarter of the way around, we would be at pi over 2. So they illustrate that in these diagrams here. So if you're moving a distance of pi over 2, you're going to end at the terminal point 1, 0. If you move a distance of pi, you're going to end at the terminal point negative 1, 0. 3 pi over 2 would be 0, negative 1. And then if you move 2 pi around the circle, you would end back up at 1, 0. So it doesn't matter what distance they give you. For now, you're going to end at these nice terminal points that are going to be on the axis. In the future, you might end at the 30-degree or the 45 or the 60-degree increments in any of the quadrants. So our last example for today is just to get you thinking of these terminal points and how to think of the radian movements around the unit circle. So if you need to, you can draw a little picture. There's your axis, and It says find the terminal point on the unit circle determined by each value of t. So think of t as a distance. This is telling you how far around the unit circle you want to go. So here for part A, t is 3 pi. So if I start and go halfway around the unit circle, that's pi, that's 1 pi. Then if I keep going again, that's going to be 2 pi. And to get to 3 pi, I have to keep going. I have to go around another half. Okay? So right there, that's where I'm going to end. That's my 3 pi. That's a distance of 3 pi. And that terminal point then is going to be -1, 0. So you can go around the unit circle multiple times in either direction. So don't be upset or afraid if your paths kind of overlap. Okay, for part B now, here they give you a negative distance. So remember, your starting point is over here, and if it's a negative distance, instead of going up and counterclockwise, you're going to go down and clockwise. And we're just going to move pi, so that's going to be 180 degrees. It's a semicircle. It's halfway around the unit circle. So again, my terminal point is going to be -1, 0. So for part A and part B, we got the same answer. You're going 2 different distances, but you're ending at the same location. And that can happen. That's okay. And then part C, again, this is also a negative distance around the unit circle. So that means we're going to go down from our starting point and we're going to go clockwise. But this time, my starting point is here. I go down pi over 2. That means I'm only going halfway to pi. So I'm going to end right here. And that terminal point then would be 0, -1. So, like I said, for now, these terminal points are going to be the nice points that are on the axes. And here's just a little book explanation of what we just went over. Okay, so your homework tonight seems a little short, but these are very important concepts that you need to make sure that you're getting down and getting comfortable with. You want to be very comfortable with radians, be very comfortable with fractions. And if you have any questions on this stuff, come on in and see me before school.